Welcome to this video, everyone, where we're going to take a look at a problem that I've chosen from an old Advanced Extension Award past paper. So the Advanced Extension Award, the AEA in mathematics from 2005, and we're going to be looking at question 2 from that past paper. So I'll leave a link in the description to this video so that you can download the past paper and you can see the problem for yourself, and you can maybe have a go at some of the other problems on the paper. This was the Advanced Extension Award paper that I sat back in the day before I started university. So it's good to revisit some of this stuff and just be sure that I can still actually solve the problems from it. So we're looking at question 2. Let's get straight into it. And it's a trigonometric equation that we need to solve. So you need to be on top of on the ball with your trigonometric identities, things like this. There's no calculator available. We've got to do all of this without a calculator, so you need to make sure that you're on top of exact values and things like this of certain trigonometric functions, so things like square root of 2 over 2, root 3 over 2 and stuff like that. Okay, so let's have a look. So for in the range 0 is less than theta is less than 2 pi, solve the equation. Let me get this right. So it's sine 2 theta plus cos 2 theta, 2 theta plus cos 2 theta, and is it plus 1? Plus 1 equals square root of 6 times cos theta. Okay, so when I'm trying to solve a trigonometric equation like this one, what I'll usually initially notice is that here I've got the 2 thetas and here I've got the theta. So that kind of clash between the multiples of theta tells me that I need to bring everything, there needs to be some uniformity in that respect throughout the equation. So either I need to derive an equivalent equation in terms of 2 theta, or what's probably going to be easier, to derive an equivalent equation in terms of theta, because I've got all my double angle identities, and yes, you need to know them. If you do rely on formula books, by the way, to bail you out for certain things, then all I can say is that you probably haven't had enough practice with, if you don't know your trigonometric identities and things like that off the top of your head, or you don't have a good idea what those identities are, it probably means that you haven't done anywhere near enough work with them. And what that means is that even if they're in the formula book, so you can just kind of you don't have to remember them in theory, what it means is that you probably won't really be familiar with how to use those trigonometric identities. And it's not just trigonometric identities, it's all much of the other stuff as well that's in the formula book. Obviously, statistical tables, you're not really expected to learn statistical tables off the top of your head, but trig identities, derivatives, standard derivatives, standard integrals, things like this, quadratic formula, whatever else is in the formula book in that respect, if you don't know these things, by the time it gets near to your exams, be worried, really, because it's a good sign that you haven't used those things enough, because if you have been using them, if you've been using them properly, you'll tend to just remember them. Okay, so that's not to say that, we're all human, obviously. We all kind of forget things from time to time, so that the formula book can be used as a kind of last resort if in the exam you just have a bit of a brain fart or something like that, and you just can't quite remember what it is that you need to remember, but because of the stress or whatever is getting to you, fine, okay, use the formula book. But if you're going into your exam deliberately with the intention of relying on the formula book to bail you out, then this is not a good sign. Okay, so I'm going to be using double angle identities here. So I don't know exactly, because when it comes to cos 2 theta, there's a choice of possibilities. I'm just going to kind of play around with things a little bit until I find something that works. Okay, so let's go for sine 2 theta is 2 sine theta cos theta. And okay, one thing that I do notice though is that I've got the +1 here. Maybe I could get rid of that if I were using the right trig identity. So maybe I use 2 cos squared theta minus 1 here. Cos squared theta minus 1 plus 1 equals √6 cos theta. I mean, it wouldn't necessarily make any difference if I didn't choose. Maybe this is the wrong one, or maybe maybe this is the right one, but maybe I choose a different version of cos 2 theta, maybe cos squared theta minus sine squared theta. It doesn't really make any difference. It's just, you just got to play around with things. Just try to notice as much as you can and make things as easy for yourself as you can. And again, this is really getting this experience, actually dealing with trigonometric identities, things like that. It's essential before your exam that you get plenty of practice with these things, because you need to see them used in all sorts of different scenarios, and through use you will tend to remember them. Okay, you'll tend to remember them quite well in various contexts. So cancel. This is actually looking quite good, because now I can see that I've got a common factor of cos theta throughout here. So let's go for something like, let's just bring everything to one side. So I've got 2 sine theta cos theta plus 2 cos squared theta is equal, minus √6 cos theta equals 0. Take the cos theta out as a common factor, cos theta. So what am I going to be left with? I'm going to be left with 2 sine theta plus 2 cos theta minus the square root of 6 equals 0. So one possible solution to this is going to be cos theta equals 0. Remember the range that we're in, so when is cos theta equal to 0? In the range 0 to 2 pi. It's here at pi by 2 and 3 pi by 2. Make sure you know your graphs of trigonometric functions. If you don't, okay, so theta equals pi by 2 or 3 pi by 2. So we've also got the 2 sine theta plus 2 cos theta, 2 cos theta minus √6 is equal to 0. So at this point, it might be worth, now if we didn't have the √6 here, this would be easy, because we could just bring tan into things, divide through by cos theta, for example, but alas, that's not the case. But what I do know is that sine theta plus cos theta can be written in the form r, and it doesn't really matter whether I choose sine or cos. Let's just go for sine. Sine theta plus alpha, right? So what's this going to be? So sine theta plus cos theta, this is going to be identically equal to square root of 2 sine, and it's going to be theta plus, I reckon it's going to be what, pi by 4, isn't it? Okay. I mean, we can always double check this, by the way. If you're unsure, just expand it back out. Okay, so let's check it, just to be on the safe side. So expand this out, you get √2 sine theta cos pi by 4 plus √2 cos theta sine pi by 4, cos pi by 4 √2 over 2. So √2 times √2 over 2 is going to be 1. Sine pi by 4 √2 over 2. √2 times √2 over 2 is equal to 1. Sine theta times cos theta. Okay, we're golden. So square root of 2 sine theta plus pi by 4 minus √6, or equals √6. Okay, a little bit of simplification here. Sine theta plus pi by 4 is equal to √3. That's not, oh, sorry, no, I thought something was wrong there, because that wouldn't have any solutions to it. I missed the 2 off, didn't I? 2 sine theta cos theta, 2 sine theta. So this is going to be, right, that's better. Sine theta plus pi by 4 is going to be root 3 over 2. Phew. Thought there was going to be no solutions then. So, do bear in mind this. So, you can either solve this directly and take this into consideration, or alternatively, you can make a substitution. What substitute? Phi. So let's say phi equals theta plus pi by 4. In that case, theta phi is going to be between pi by 4 and 2 pi plus pi by 4. What's that? 2 pi plus pi by 4. 9 pi by 4. Obviously, yeah, of course. Right. And the equation that I need to solve now is sine phi equals root 3 over 2 in this range. Okay, so sine phi equals root 3 over 2. What does sine look like? Something like that. Cut it off here at pi by 4. Cut it off here at 9 pi by 4. I know there's a solution at pi by 3 for this, which is going to be, okay, it's not drawn very well, but it's going to be over here somewhere, pi by 3. So I'll have another solution at 2 pi by 3. And the next solution along would be here, which would be out of range. Okay, so I would only expect 2 solutions in the given range anyway. So once I've got them, I've got them. So that means that phi is equal to pi by 3 or 2 pi by 3. So that means that theta is equal to pi by 3 minus pi by 4, or 2 pi by 3 minus pi by 4. What's that going to be equal? That's going to be pi by 12. 8, that's going to be 5 pi by 12. Okay, so what are the solutions to this equation? Solutions are theta equals, you don't have to write them in ascending numerical order or anything like that, but I think if I do, then I'm going to get pi by 12, 5 pi by 12, pi by 2, and 3 pi by 2. As long as you get all of the solutions, it really doesn't make any difference. And that's it, okay? So we've got all of our possible solutions as far as I can see. I don't think I've missed any, but another thing that I would expect as well, because we've got the range of 2 pi here, even though we don't have the endpoints in there, I would expect 4 solutions here because of the 2 theta appearing, okay? It's little patterns like this that you'll tend to pick up with experience. You'll start to predict how many solutions kind of to expect. There could be fewer than 4, but typically I would expect 4 solutions. In a 2 pi range, when you've got an equation that involves 2 theta, I would expect 4 solutions. In the same way that if the equation just involved theta, and no powers, by the way, no powers of sine or cos or anything like that, then you might only expect 2 solutions. Okay. Okay, and that's it. So that brings us to the end of this problem. A nice little question. Not really any difficulties involved. You just got to make sure that you know your trig identities, make sure that you know your exact values, and that you're okay with things like this, writing the r sine theta plus alpha. By the way, on an advanced extension paper, it's very common for you not to be given too much guidance, just told what to do, okay? Whereas if this was I could imagine something like this coming up on a normal maths, A-level maths exam, but with modifications, so it would be much more guided, okay? You might be asked to show that this equation can be written in this form. and then show that this can be written in this form, and so on and so forth. I'm not saying that this would appear on a normal A-level maths exam, but I could see it. I could imagine it coming up, as long as it was modified with a bit more guidance. But on an advanced extension award paper, you're given very little guidance, you're left to your own devices. Okay, but that brings us to the end of this problem, and it brings us to the end of this video. So thanks a lot for watching, guys.